Welcome everyone. Today we have another new episode, and today we're gonna discuss about this world new journey about the Marx scientific issues and other things. We have our guest, Mr. Majid Ullah. He's from USA. We have our another guest, Mr. Anthony. He will join. I think he has some internet related issues. So let's start discussions with Mr. Majid Ullah. So hello, how are you, sir? How are you today?
Thank you so much, Sharif. It's a great privilege to be here in your show. So I'm very good. Good evening from here. Basically, now I'm here in Pakistan. So good evening from Pakistan.
Okay, okay,
Yeah.
okay.
So
Understand. Yeah.
a brief introduction of mine. Basically, I'm electrical engineer and have expertise in energy management and sustainability with a strong social focus from Arizona State University.
Okay,
So
okay. Yes.
yeah,
Like, can you share a few of your professional backgrounds with us? Yes.
yeah. So like there is a school like SFIS School for the Future of Innovation in Societies, like the basic mission of that, like how to eradicate poverty through energy innovation and creating some job opportunities for the people who are living in rural communities. So, like to evaluate the social value of energy services and then creating a decentralized workforce for decentralized communities. So it is one of the mission of this project. I also working as an independent consultant with different NGOs and with some government like the local energy sectors. Like renewable energy. So then we have in this like mm, hydro, uh, small hydro, um, solar and wind energy. But I have also some like I just have some literature reviews on some Mars, like the Mars project, which Anthony is doing. So it's really a wonderful opportunity to be here and discuss the things here. So I think we should need to wait for Anthony, or I we should need to start from here.
Hmm. Yes. Like, we have a plan to discuss about Marx and the opportunity in the Marx. So, what do you want to share as a engineers? So, what the
Yeah, yeah.
opportunity we have in Marx? Yeah.
Yeah, of course. Like I will share. Like back in 2017, there was a conference, astronautical congress. So there were so many sensations from Elon Musk in this speech. So that one sensation was last the return from Mars with fuel generated by solar electric power. So it's like a more technical. So since travel is very expensive because enormously expensive rockets are thrown away after a single use. If we talk about the Falcon 9 managed to land the first stage 16 times in a row, and it was really a successful mission with the new Unifield BFR, a rocket for all missions. So the entire rocket should be able to use again and again. So what was like the problem, like the challenges was like then the return from Mars, like it was really a big challenge for the scientists, also for the NASA. So in 2022, two cargo ships, in 2024, two cargo ships and along with two passenger ships are expected to land at Mars, since there are 85 tons each spacecraft, around 150 tons payload with empty tanks on Mars. So 1100 tons of fuel per spaceship are missing for the return to Earth. So to get back the six spark on Mars ships are needed, like if I remember, 1440 tons of methane and 5160 tons of oxygen, which is required. So these should be produced in just 2 or 2 years until the next launch window. So it's like a very expensive thing. So when Earth and Mars are in a favorable position, so the atmosphere is thin but consists of 95% of carbon dioxide. The rock should contain should contain water. So there should be water with energy input for raw material and some procurement and synthesizing. So most I will come to now the electricity, like how much we will consume on this. So the estimate the electricity requirement at that is just estimation, like 45 gigawatt hour energy. So here are three components. If we talk about 45 gigawatt hour energy, so 18 megawatt photovoltaic from PV, 54 megawatt hour from batteries. So it is a backup, and 3 megawatt power to gas system. What this weight? So conventionally a 290 watt module weighs like 18 kg. If we add an additional 20 watt per kg, so 20 kilowatt per ton, 15 100 tons per 18 megawatt does not work at like for one spacecraft has only 150 tons payload. So that's the calculation from my side. So it's like the big challenge is like uh, the two returns from from the Mars. So it was like it was also a question for Alan. So like how we will return from the Mars. So then
Mhm. Thank you. I want to
then
know what the present conditions in Pakistan, like what's going on in Pakistan about this COVID and yeah.
Oh, yeah. So the situation here is now good, like no COVID-19 cases so far. So all the activities are open. The schools, the the universities, everything is open, like small
Okay.
businesses. So now we have really a good situation here.
Thank you.
Like,
Thank you. Thank you. I want to add Mr. Anthony. Yes, Mr.
Listen,
Anthony.
my humble apologies. My humble apologies. Again, the internet connection is absolutely outrageous. My humble apologies.
Yes. No
Yes,
problem.
I would like to, if I may, I would like to just give a brief overview with Mars in terms of its development, in terms of terraforming and so forth. So,
yeah,
Mars was actually formed 4.5 billion years ago inside a solar nebula. Inside a solar nebula, 4.5 billion years ago. In terms of its mass, it's just under half the size of our planet. Just under half the size of our planet. In terms of its early development, because of the gravitational forces of Jupiter, Mars was actually dwarfed during its actual early development because a lot of raw material that would have actually contributed to its growth was sucked into Jupiter's enormous gravitational field. The gravitational forces of Jupiter actually consumed enormous amounts of raw material that would have actually contributed to Mars's growth and development as it formed and reached hydrostatic equilibrium. So Mars was actually dwarfed as a result of the neighboring gas giant Jupiter. In terms of actually the asteroid belt is actually remnants of a planet that should have formed but couldn't because of because of Jupiter's enormous gravitational field. Because of Jupiter's enormous gravitational field, it's the largest planet in our solar system. Because of the gravitational forces of Jupiter, it prevented a planet from forming, and this is why we have the remnants of the asteroid belt. Now, in terms of distance between Earth and Mars, interestingly, the distance between Earth and Mars is variable due to their elliptical orbits around the Sun. At their closest point, they're separated by a distance of 57 million kilometers, approximately. And at their furthest point, they're separated by a distance of 401 million kilometers. Again, this is just approximately. Yeah. So in terms of actually reaching Mars, you'd have to set off to Mars during the point when they're at their closest points, which would be approximately 57 million kilometers. 57 million kilometers, yeah. In terms of atmospheric composition, Mars's atmospheric composition is actually 95% carbon dioxide, approximately, 3% nitrogen, 1.6% argon, and the rest is minimal traces of water and oxygen. In terms of farming on the red planet, well, we know that the soil is very fertile and contains the crucial elements for life. So in terms of farming in the future on Mars, this is actually possible because the soil is very, very fertile. In terms of its average temperature, it's minus 63 Celsius. That's the average temperature of Mars is approximately minus 63 Celsius. And it takes Mars around 687 Earth days to orbit the sun, one revolution. So basically, once we colonize Mars, we're going to need a 24-month calendar. One Martian day is 24 hours and 40 minutes. Now, in terms of actually terraforming the planet, it all comes down to two key things: thickening the atmosphere through a greenhouse effect, and actually maximizing sunlight absorption. And as we maximize sunlight absorption, you heat the planet, the ice caps melt, and you actually produce rivers and lakes on the planet. Incidentally, through electrolysis, we can actually produce electricity on the planet. Is easily done. AC current through a water solution separates oxygen atoms from hydrogen atoms. You then store the hydrogen, pump hydrogen into a fuel cell, recombined with oxygen, you produce electricity. So it's easily achieved once the planet is terraformed. Now, in terms of terraforming the planet, how do we terraform the planet? Well, one of the ways would be to redirect asteroids and comets to actually crash into the Martian surface. As a result of this, you would produce enormous amounts of heat. And not only that, release enormous amounts of CO2 into the atmosphere. As I mentioned to you before, Mars's atmosphere is 95% approximately carbon dioxide, 3% nitrogen, 1.6 argon, and with the rest is minimal traces of water and oxygen. So you would initiate a greenhouse effect, thickening the atmosphere through redirecting asteroids and comets to actually strike into the Martian surface and producing enormous amounts of heat. Another way would be actually to pump enormous amounts of greenhouse gases into the atmosphere. We can do this by importing hydrocarbons. Ammonia is a very strong greenhouse gas, methane as well. So by pumping enormous amounts of greenhouse gases into the atmosphere, Mars's thin Martian atmosphere, over time, you thicken the atmosphere and you create an Earth-like atmosphere suitable for human existence. So this is another way to pump enormous amounts of greenhouse gases into its thin atmosphere. Another way is actually the importation of algae. Algae actually breaks down carbon dioxide and produces oxygen. Algae also absorbs enormous amounts of sunlight. So you reduce the planet's albedo and you can actually heat the planet through algae. And as I said, it breaks down carbon dioxide and produces oxygen. So this is another way. Another way would be to utilize, sorry, are you there?
Yes.
Okay. Another way would be to utilize the whole thing of orbital mirrors. Orbital mirrors maximize sunlight absorption. Orbital mirrors maximize sunlight absorption, which means you reduce the planet's albedo. This is basically, you reduce the amount of sunlight that is reflected back out into space. Every astronomical body has an albedo reading. Earth is 0.39. Our planet absorbs enormous amounts of sunlight, the oceans, forests, jungles, and so forth. So every astronomical body actually has an albedo reading. Mars's albedo reading is actually, it fluctuates. But going back to my point, through orbital mirrors, we maximize sunlight absorption, we heat the planet, you melt the ice cap, so you create rivers and lakes, and release CO2 into the atmosphere. And so you thicken the atmosphere, and over time, you create an Earth-like atmosphere suitable for human existence. So these are the key points. Asteroids, redirecting asteroids and comets to crash into its surface, algae, pumping enormous amounts of greenhouse gases into its atmosphere, methane, ammonia, and so forth, by importation of hydrocarbons. This is a very important point. And as I mentioned, orbital mirrors will maximize sunlight absorption. You heat the planet, you heat its surface, you melt the ice caps, rivers and lakes are formed, and you release CO2 and you thicken the atmosphere over time and you produce an atmosphere that is suitable for human existence. As I mentioned, once we have water on the planet, water is crucial. It's a crucial to human existence. And through electrolysis, as I've mentioned, we can actually generate electricity. DC current through a water solution, you separate oxygen from hydrogen, oxygen atoms from hydrogen atoms. You then pump hydrogen into a fuel cell, recombine with oxygen, you generate electricity. So these are some of the ways that we can actually benefit from actually producing, obviously, um, rivers and lakes on Mars and so forth. But these are crucial to terraforming. Now, just very quickly, in terms of the problems that could actually arise with Mars, Mars lacks a magnetosphere. Mars does not have. Sorry, are you there?
Yes.
Mars does
Yes.
not have a magnetosphere. Mars's magnetosphere was wiped out as a result of multiple asteroid strikes. I would say probably around 19 to 20 asteroid strikes. At least this is what we are led to believe. NASA is led to believe that around 19 to 20 asteroid strikes would have actually wiped out Mars's magnetosphere over time. So it doesn't have a magnetic field, which means that Mars is subjected to enormous amounts of cosmic radiation. Highly energetic particles from supernova, pulsars, and neutron stars. Very deadly, lethal cosmic radiation from pulsars, neutron stars, and supernova. And because it doesn't have a magnetic field, Mars is subjected to enormous amounts of cosmic radiation. So there is a problem here in terms of colonizing the planet for mankind. Mars lacks a magnetosphere. So how can we override this problem? One of the ways would be to actually create, once we're on Mars, create domes, indoor domes, that actually are built from special alloys. And these special alloys are able to repel cosmic radiation. So once we're on Mars, to actually build an indoor world and actually to use certain alloys that are able to repel deadly cosmic radiation. And that would be one of the ways to override the problem. Obviously, once you are exposed to Mars's landscape, once you go outside into its actual landscape, then you will be subjected to enormous amounts of cosmic radiation. But in terms of actually building structures that have the capacity to repel deadly cosmic radiation, this would be one way to actually help man colonize the planet. So this is a very important point. Not only that,
Yeah, that's great.
there is also the problem of solar winds. Once we produce an atmosphere on Mars, we create an atmosphere on Mars as a result of the greenhouse effect over time, as I have mentioned. The problem is retaining the atmosphere. Now,
I think Mr. Anthony has internet related problem. No problem. When he joins, we're going to discuss on that particular points. So Mr. Majid, like he is
Yeah,
discussing about the
yeah. I
solar
would like.
projects and yes. What do you want to add
Yeah,
regarding
so I
this
would
as
like
you
to
have
add.
expertise?
Yeah. I would like to add some things like Annie said about the radioactivity and some rays. Like in Mars project, what is certainly obvious is radioactivity. So cosmic rays, like sun flares, like Mars has zero magnetic fields. As according to Annie, there has been no answer from Mars as how he will accomplish this mission, except vague thoughts about a water shield about the space vehicle. So, and certainly does not even deal with the intensity of habitation. So we cannot like sit up any habitation. So should we have a new planet for the people? So now this is the questions like for all. Sure, but surface villages are nonsense if we talk about. So just make the calculation with the air pressure and best to build in the underground as deep as the air pressure, which equals the weight of the material above. So about like 15 to 20 meters deep. So on the surface, only PV. So if you talk about photovoltaics, the energy. So only at the travel, nothing 20 meter below the surface. So it will like consume too much energy. So that was the point I would like to add with the any discussions about the radiations. So the basic drawback is obviously the radiations. So we have like that.
Mhm. Yes.
Yeah.
One
So
specific points, like in present situations, what do you think that we should have a make a plan to move to the Mars, or we should take this kind of plans?
yeah, yes, like as I talked before, like
Mr. Anthony, can you hear
they are
me? Okay, you please continue.
like yeah, yeah. So like as earlier I talked, like maybe in 2022 or in 2024, like 4 cargo spaceships are to fly to Mars. So
Hello,
this is the goal. They received these goals. So more than half
hello.
of the cargo capacity is already needed to the energy supply. So, but even if the system would occupy the entire 600 tons, like of cargo space, so in just 2 or 2 years, so the next start window, like 11 times as much mass of fuel will be produced. So it is like very expensive, but but it is possible, like it is doable. So maybe in 2022 or 2024, so we would expect like the human life be on Mars.
Mr. Anthony, can you hear me? Anyway, I think he has internet problem. So beside that, like example,
Yeah,
I want to know like what the vaccine situations right now in Pakistan. Like, is there any deals or anything happening right now in Pakistan's or COVID situations, and especially if we share something about healthcare system, and even though if the human resources and we build up our new platform in Mars, what kind of system we have to integrate it in the Mars? What's your idea and
yeah.
plan?
Actually, like the current situation, like if we talk about the COVID-19, so like as I discussed earlier, everything is open. So, but people here not following any SOPs. Like we have some certain rules for that. So now, like in the second wave COVID-19, we will have more cases. So maybe the government do not want, but definitely if there is, so they will close all the schools because I have seen a few schools which are closed because some of the cases are noted by the government. So the situation here is like not good. So we have like the weather transition is also like one of the matters. So now in northern areas there is more cold. So people are just suffering from fever. So and here the vaccines, like people do not like they are very expensive, the vaccine here in Pakistan. So for poor people, it's very difficult to buy anything. So this is like really not good for the Pakistan. So but we wish like we have some like in the early stage we have very less cases. So
Mhm.
we are doing good now so far. So maybe the second wave will just pass. So we are hoping for the best.
Okay, thank you, Mr. Anthony.
Hi,
Yes, what
Sharif.
makes you
Sorry,
want
Yeah.
to add?
can I finish off? Listen, I'm so sorry. It's been terrible with the internet today. I was talking about solar winds. Solar winds, basically, in terms of cosmic radiation, and I mentioned about the problems of cosmic radiation on Mars, from ultraviolet light and supernova and so forth, gamma rays and so forth, because it lacks a magnetosphere, because the magnetosphere was wiped out as a result of multiple asteroid strikes. At least this is what we're led to believe. So Mars is subjected to enormous amounts of cosmic radiation. And as I said, one of the ways to actually deal with that is to actually, once we colonize the planet, once we build domes, um, domes on Mars to actually build these domes from special alloys that have the capacity to repel deadly cosmic radiation, highly energetic particles from supernova, pulsars, neutron stars, and so forth, gamma rays, ultraviolet light, and so forth. So to build these domes from special alloys that have the ability to repel deadly cosmic radiation. So this is very important. And I also mentioned the fact that the Mars's atmosphere, once we produce an atmosphere on Mars through the greenhouse effect, thicken the atmosphere, create an atmosphere on Mars, on the red planet. The problem is to retain the planet, to actually maintain the planet is a problem in the sense that solar winds would actually eat away at the atmosphere. So this is a problem. In fact, as we speak, Mars's thin upper atmosphere is constantly being bombarded with solar radiation, solar winds, radiation from the sun that's actually eating away at its upper atmosphere as we speak, the ionosphere and so forth. So once we produce an atmosphere on Mars, we could still have the same problem, solar winds eating away at the atmosphere that we produce through the greenhouse effect and so forth, as explained. So how can we overcome this? Well, one of the ways is to, NASA was speaking about launching a giant magnetic shield out into space that would actually make up for Mars's lack of a magnetosphere. So it could actually protect Mars against solar winds. This is one way that we could actually bypass the problem to a certain extent, and also at the same time nullify some of the cosmic radiation from supernova and so forth. So this is one way we could help nullify this problem. In terms of the Martian gravity, Mars has a very weak gravitational field. This is also a problem when it comes to retaining an atmosphere. Once we produce an atmosphere on Mars, the atmosphere can be easily lost to outer space. The reason why is Mars has a very weak gravitational field. Now, atmosphere and gravity, in a sense, in quotes, are intercombined. In order to retain an atmosphere, you need to have a certain gravitational field. Mars's gravitational field is very weak. So over time, Mars, the atmosphere that we would produce on Mars through terraforming could be easily lost to outer space because the gravitational field of the planet would not be strong enough to retain the atmosphere that we create. So this is a problem. And one way to actually overcome this is to actually keep the planet very, very warm. So it's an ongoing process to replenish the atmosphere and to keep the planet very, very warm. This would be one way to actually help maintain an atmosphere. So this is something that we need to rethink about because as I said, because of the weak gravitational field of Mars, the atmosphere could be very easily lost to outer space. So we need to maintain the atmosphere. And the only way we can maintain the atmosphere is to replenish the atmosphere and to keep the planet very, very warm. And this can be done through orbital mirrors and all the explanations that I have given before.
Yeah.
Understand. Yes. There is a specific questions. And
I had one more thing. Just one more thing before you ask the question. If I may. Okay.
Yes.
Yeah. Very quickly. In terms of the lack of gravity, the weak gravitational field of Mars, as I said, Mars, the planet Mars, is basically a very weak gravitational field, just under half the size. The planet is just under half the size of our planet Earth. So the gravity on Mars is very weak, very, very weak. And so there are going to be also health hazards because of this. Humans adapting on the red planet are going to go through a time of adaptation. But of course, the weak gravitational field of Mars will cause adverse effects biologically, neurologically, in terms of the way the synapse operates. Just all round, the human body will go through dramatic changes. Obviously, organism and environment work together over time. Man will adapt, but over time, man will adapt. But initially, a lot of humans on Mars will experience a lot of adverse effects in terms of health, in terms of cosmic radiation, and actually adjusting to a much weaker gravitational field. As I said, Mars is just under half the size of our planet, in terms of mass. It has a very weak gravitational field. So this actually poses enormous amounts of problems on our bodies to be exposed to a much weaker gravitational field. So it's going to be a time of adaptation. But of course, over time, organism and environment will adapt, but we will go through a stage where there will be a lot of adverse effects on the body, neurologically, psychologically, as we get to grips with a different environment. There's going to be dramatic psychological differences in terms of the way we see things and so forth, and in terms of our actual body, there's going to be a lot of adverse effects, and of course, the problem of cosmic radiation. But one way that we can overcome this problem of the weak gravitational field of Mars is that once we create domes on Mars through a centrifugal force, we can simulate an Earth-like gravity. So we can actually bypass that problem in this sense.
Mhm.
Okay.
Yeah.
Thank you. I want to take our audience questions, and they have very good response. Anyway, Mr. Araf Mehras, his question is that how to possible to build a sustainable colony on Mars? Yeah.
I think I just answered that actually.
Yes, but
Okay.
I
That's
think
okay.
that,
It's okay.
Mr. Majid, do you want to add something?
Yeah, it is possible. Like
I can take that question if you like.
Yes, after Mr. Majid, if you do not mind, Mr. Majid, actually, audience asking me, requesting me, if you speak loudly because they cannot hear you, because there are still many audience. They are requesting you to speak
Yeah,
loudly. They cannot hear clearly. Yes.
okay, thank you. Yeah,
Yes,
so
Mr.
can you
Majid,
hear me?
please. Little bit of
Can you
loudly.
hear
If you
me?
speak loudly, not clear.
Yeah, yeah. So like I talked earlier, like in 2022, like 2 cargo ships, maybe in 2024, 2 cargo ships and 2 passenger ships are expected to land at Mars. So that will be the colonization of the Mars. So since there are like 85 tons each spacecraft around and 150 tons payload with empty tanks on Mars, so it's like 1100 tons of fuel per spaceship are missing for the return to Earth. So the basic question is like the return from the Mars. So it's like a challenge for the scientists, for the people. So maybe it is possible, like colonization on the Mars.
Okay. Okay. Thank you. Yes, Mr. Anthony. Yeah.
Well, in terms of actually, so can you repeat the question again, please? So I just want to repeat the
Uh,
question again.
yes. Question is here's how to build a sustainable colony in Mars. Yeah.
Well, sustainable colony, it all comes down to basically mentioning the problems that I've mentioned here. A sustainable colony, we need to look at the problems of cosmic radiation. This is a major problem. Cosmic radiation, as I said, because Mars lacks a magnetic sphere, lacks a magnetic field, because of multiple asteroid strikes, wiped out Mars's magnetic sphere. Mars is subjected to enormous amounts of cosmic radiation. So how can we deal with this? As I said, from the cosmic radiation comes from supernova, pulsars, neutron stars, and so basically you're bombarded with enormous amounts of highly energetic particles, gamma rays, ultraviolet light, and so forth. Very highly energetic particles. Now, one of the ways to overcome this and to actually build a colony on Mars would be to create indoor domes that have the capacity to repel deadly cosmic radiation. So in other words, we build these structures from special alloys that have the capacity to actually repel deadly cosmic radiation. So once inside these domes, humans will be protected, and thus the colony can move forward. So this is essentially one of the key ways in terms of, as I said before, in terms of adapting to Mars's gravitational field. Obviously, the weak gravitational field of Mars will have many adverse effects on human beings in terms of the way the mind functions, the body in general, the biochemistry of the human body, even at a neurological level. And of course, there is also psychological implications in terms of adapting to a new alien world. So man, over time, will adapt. But in the beginning, there will be adverse health effects. One of the ways to actually deal with this in terms of, again, going back to the question, how to maintain a colony would be to have, through a centrifugal force in physics, to have domes through a centrifugal force, we can actually simulate an Earth-like gravity. So we can bypass that problem through a centrifugal force. So these are some of the key ways that we can actually maintain a colony on Mars. Otherwise, as I said, cosmic radiation is a major problem. And as I mentioned before, of course, in terms of maintaining the atmosphere that we create on Mars through the greenhouse effect, through the, as I've mentioned before to you, through pumping enormous amounts of greenhouse gases into the atmosphere to actually thicken the atmosphere. Hello?
Yes.
Are you there?
Yes, yes.
Yeah.
Can you hear
to
me?
thicken the atmosphere and so forth. Obviously, we need to maintain the atmosphere. And the only way to maintain the atmosphere, because as I mentioned to you before, which is very, very important, in order to maintain the atmosphere, because of the weak gravitational field of Mars,
I think still he has. Yes.
on Mars can easily be lost. Hello? Sharif,
Yes.
can you hear me?
Yes, continue.
In order to maintain an atmosphere on Mars, once we create an atmosphere through the greenhouse effect, can you hear me? Yeah.
Yes.
Okay. Yeah. Once we create an atmosphere through the greenhouse effect, as I've mentioned before, thickening the atmosphere, absorbing as much sunlight as possible through orbital mirrors and so forth, and the importation of hydrocarbons, algae that breaks down oxygen, carbon dioxide and produces oxygen and so forth, and actually absorbs enormous amounts of sunlight. Once we create an atmosphere, maintaining the atmosphere is very important because it could be easily lost to outer space because gravity and atmosphere is intercombined. In order to retain an atmosphere, you have to have a certain gravitational field. Mars is a very small planet, so it would that we would create on Mars could be easy. Hello, Sharif, can you hear me?
Yes, please continue. Yeah.
So the only way to do that in terms of retaining an atmosphere is to keep the planet very, very warm. To keep the planet very, very warm and to replenish the atmosphere. So once we create an atmosphere on Mars that's suitable for human existence, it's not a question that's it. It's an ongoing process. You see what I'm saying? It's an ongoing process because over time it could be lost. It could be lost to outer space. So the atmosphere has to be kept very, very warm in order to maintain the atmosphere. Otherwise, we have a problem. As I've mentioned, Mars's gravitational field is not strong enough to retain an atmosphere. So we have to look at that. So it's all about maintaining the atmosphere by keeping the planet very, very warm.
Okay, thank you.
I think this answers this question in abundance. Yeah.
Okay, I want to add another question. Gary, his question is that suppose there are 1 million people on Mars, would they be divided into colonies, thereby creating many countries? Mr. Anthony.
Yeah. The question that he's posing is actually something very, very futuristic, even in terms of colonizing Mars. Obviously, over time, once Mars is colonized, and you know, I'm going very, very much into the future. Obviously, there's going to be, in a sense, I wouldn't say to the extent where we're going to be having separate countries as such, but it's going to be very much, shall we say, a time of adaptation for human beings. But for me personally speaking, in terms of Mars, I think it's going to be more of a question of terraforming the planet and shall we say, maintaining the atmosphere, as I've mentioned, which is essential, and so forth through the scientific techniques that I have given.
Okay, I want to take another question from audience. Mr. Majid and Anthony, both of you can give the answers. Greetings from Malaysia. Is there any other organization except NASA who are directly working to aiming for Mars? Thank you.
I'll give that to Majid.
Yes, Mr. Majid. Mr. Majid, we cannot hear you. Mr. Majid, you have to unmute yourself. Yes, Mr. Anthony, you can continue. I think he's unmuting himself.
Yeah, sorry. Do you want to? Yeah, well, I think every country has the ambition in terms of when it comes to terraforming Mars. I think a bit of ego comes into it. So yes, China, Russia, and so forth. So yeah, of course, there's always, shall we say, multiple countries that have the objective to be the first one to actually get to Mars. And of course, I think there's always going to be a sense of competition between the United States, Russia, China, and maybe various other countries. So yes, absolutely. Yeah.
Mhm. Yes,
Can you
Mr.
hear me?
Majid. Yes, yes.
Yeah, yeah, of course. So it is possible. It is a very exciting project. So countries China, Russia, so they are trying. So maybe there will be a private company to send some of their spacecrafts to the Mars. So it is possible.
Mhm,
NASA is doing.
mhm, mhm. Okay, thank you. There
Yeah.
are another question I want to take from our audience. Mr. Anthony, you can add colonizing the moon and Mars. How does mankind do better this time? Whether many private companies trying to do a successful research on Mars? Mr. Anthony, can you hear me? Yes, I think he's in has internet issues. So, Mr. Majid, yeah, Mr. Majid, can you hear me? Mr. Majid, can you hear me? Mr. Majid, can you hear me? Yes, Mr. Majid, can you hear me?
Can you hear me?
Yes. There is
Can
a
you hear
question.
me?
Can you open your mouth because our audience cannot hear you clearly? They're requesting me several times because
Yeah, yeah,
I
of course. Yeah.
I'm sorry about that. I'm sorry about that.
Okay, thank you. So,
Yes,
what
yes,
what's the question?
yes. This is the
Sorry.
questions. Yes.
Yeah. So maybe can you repeat the question?
How does mankind do better this time, where many private companies trying to do a successful research on Mars?
Yeah. So maybe there is only the ultimate creator knows the answer. Like I will discuss. There are as many opinions as there are like stars in the sky. Like none of us have the inside scoop. So I will remember, we are the blind mean of today. We can observe, examine, and experiment. So our inquiries into the nature of the physical world have borne much fruit. So we now can tap the power like of the sun and like beyond. So we have from the deepest mysteries of the universe and again new understandings, like we have harnessed the power of magnetism, electricity, and nuclear power. So it is possible. It is possible.
Yes. Mr. Anthony, yes. What do you want to add
Yeah,
about
well, I think
private?
I've mentioned now extensively a lot of the scientific techniques behind terraforming the planet, maintaining the atmosphere, as I've mentioned extensively, the greenhouse effect, and the whole terraforming process. I think I've gone into that extensively, and so forth. Now, in terms of the philosophical implications, I think really what we need to ask here, and this is a very interesting question, a very interesting metaphysical question. human or Martian, over time, will we lose our humanity on Mars? Obviously, the early colonists, I guess, will, in a sense, retain their, in quotes, human identity. But once we start to colonize the planet and humans are born on Mars, what will happen? Will we lose our humanity? Will a human born on Mars actually lose, in quotes, that identification of being human? So this is a very interesting metaphysical question, and something that I would like to raise.
Thank you. Hosneara, she asked you a question that could humans survive in extreme environment conditions?
Well, going back to what I've mentioned to you before, in terms of the lack of a magnetosphere on Mars, as I've mentioned before, and I mention again, the lack of a magnetosphere on Mars, the lack of magnetic field on Mars, but incidentally, Mars had a magnetic field. The magnetic field on Mars was wiped out as a result of multiple asteroid strikes, probably around 19 to 20 asteroid strikes. That's what we're led to believe. Now, a human being subjected to that on Mars, say a human being on Mars, subjected to that amount of cosmic radiation from gamma rays, ultraviolet light, from supernova pulsars and neutron stars and so forth, we're talking about cancer accelerated by 10. So this is a problem that needs to be rectified, and something that NASA needs to consider. As I said, the problem of cosmic radiation is a very, very big problem. I've already mentioned the fact that humans, once we create domes on Mars, these domes can be built from special alloys that repel cosmic radiation, highly energetic particles. This is one way to bypass the problem. But to be honest with you, a human exposed on Mars to that amount of cosmic radiation, there are going to be adverse effects. We talk about cancer. We're talking about cancer 10 times 10 in that environment. So there are problems there. Not to mention, as I said before, once we create an atmosphere on Mars, the solar winds from the sun, radiation from the sun, can actually eat away at the atmosphere. So these are things that we need to consider. And as I've mentioned before, one of the ways to bypass this problem would be to launch a giant magnetic shield into space that, in a sense, replaces Mars's lack of a magnetosphere. So it basically protects Mars from solar winds, protects the atmosphere, and protects humans, but only to a certain extent.
Yes, excellent. Beside this idea, just I want to know, like, in the COVID period, actually, many people have different kind of problems, and already many scientists, they are discussing that the world is overpopulated. So, what do you think? What do you think about this like this ideology? Or
Well,
yes.
Yeah. Well, that's a very good point, because actually one of my short stories, I actually write about this, how actually terraforming will actually deal with the problem of an overpopulated planet. Overpopulation is a big problem in terms of, obviously, food shortages and all sorts of economic problems that come with this. So actually, when we have an overpopulated planet, that is a very, very big problem. So thus, to have terraforming, for example, Mars, or colonizing Luna, the moon, and so forth, is actually a very good thing. It would actually help alleviate the problem of an overpopulated planet.
Mm-hmm. Yes.
Absolutely.
Yes. Mr. Majid, what do you want to add about this point? Please unmute yourself. Yes.
Actually, overpopulation, it is like a huge problem. Like if we talk about the people, so like we can see in our own country, like if we talk about India, Pakistan, Bangladesh, so we are overpopulated. So there are many problems, economic problems, energy problems. So in the future, maybe we have more problems. So overpopulation is a big issue nowadays.
Mm-hmm.
Yeah.
Mr. Anthony, like what Mr. Majid said about these developing nations, like how do you think?
I didn't hear very, very well. Please forgive me. It's very, very
Yes.
low sound.
Yes, basically, I just want to share about his idea that India, Pakistan, Bangladesh, they are the developing nations and they have a lot of problems. So in that situations, like how this kind of countries they can engage with research and Mars related research and the initiative, how they can engage with this kind of process. What's your idea? What's the practical idea you can share
Well,
with us?
again, as I said, these countries obviously they may be subjected to enormous amounts of political tension and economic tension and so forth. But as a result of artificial intelligence, as I mentioned before in my previous discussions, um, even people within, shall we say, a country where there is a lot of economic tension, political strife, and so forth, with the press of a button, so much information can be acquired. So people in Bangladesh, Pakistan, India, regardless of the economic disarray and political discohesion, shall we say, information can always be sourced via the computer, via artificial intelligence. At the press of a button now, we have multiple, infinite possibilities to learn and to keep up with what's actually happening in terms of science, technology, and terraforming and so forth. So that's my answer. Yeah.
Mhm. Excellent. Yes, Mr. Majid, like example, as you are an engineer, what the scientific situation right now in Pakistan, your country like India, Pakistan, Bangladesh? How do you want to share these things?
Yeah, so first of all, I would like to tell you that there is no laboratory, like no research activities um, regarding space. So, and even we do not have artificial intelligence engineers in Pakistan. So it's a major problem for us. No space activities here. So maybe the people here are very intelligent, very clever. So, but we are still lacking in technology. Like we are just borrowing technologies from other countries, from Europe, from America. So here the culture of technology, like the civilization of technology, is not so developed. So still we are lacking in this sector.
Mhm. Yes, Mr. Anthony. At present, in the COVID-19 situation, many countries has lot of economical challenges. So, what do you think? This kind of research and these things need lot of funding, lot of financings, and many more things. What do you think? Is it practically possible? I think Mr. Anthony has some sort of internet issues. Anyway, Mr. Majidullah.
Hmm. Yeah, it is possible.
Oh, sure. Can you hear me?
Like
Yes, can you hear me?
Sorry. Yeah. It's the sound faded. My apologies. I'm going to have to
Yes.
get a new modem here. No
Okay.
question. Yeah.
Okay. Like, what do you want to add about the research on Mars and this
Well,
kind of thing?
the research. Well, I mean, obviously, as we have mentioned prior, obviously, in terms of an overpopulated planet, so the logical conclusion would be, obviously, to terraform Mars and obviously Luna as a potential lunar colony, the Moon, and so forth. So this is a very, very logical application in the sense that if the planet becomes overpopulated and so forth, we need to think about terraforming. And Mars, as I said, going back to what I had mentioned prior, in terms of its the planet itself, in terms of the soil is very fertile. So in terms of farming in the future, there's absolutely all the key essential elements crucial for life within the soil. So we could farm on Mars and so forth. So from a logical perspective, in terms of overpopulation and so forth, we need to think about colonizing Mars because Mars is the planet that is most terraformable, as mentioned. No question about it.
Yes, thank you,
yeah.
thank you. Actually, our audience has a lot of questions, and they really enjoy about the Mars and this kind of things. And especially, we know that both of you are scientists, and especially Mr. Anthony, you are scientific. like writers and you have many books. So World Talent Economy Forums always want to recognize the talent people like you, Mr. Majid, and we are trying to engage with lot of talent people around the world. And with our Asia Research and Development Institute, as well as Al Noor Academy and the World Talent Economy Forums, we are working together. So hopefully in the future we can do this kind of group discussion like this. And definitely in the futures, hopefully your internet connections and everything will be fine.
Well,
Yes.
this needs to be rectified with immediate response. No question about it.
Yes.
Yes,
Yes.
there's
Yes.
always
Yes.
Um,
Thank you.
problems in
Yes.
a good
Yes.
communication.
Yes. Yes. Thank you. So what is the concluding remarks? I want to start with Mr. Majid, then Mr. Anthony.
Yeah, so it is like as discussed in the, it is a very exciting project. So maybe in future we will see the colonization in Mars, like the people will go there. So it is very interesting for me. So we have some bright future.
Okay. Thank you. Thank you, Mr. Majid, joining with us.
yeah.
Mr. Anthony, what's your concluding remarks?
Absolutely. To surmise, I would say that in terms of obviously the things that you have mentioned and so forth, in terms of an overpopulated planet and so on, it is logical to actually terraform. And so Mars is the most terraformable planet. As I have mentioned, the key ways to terraform Mars all come down to thickening the atmosphere and creating a greenhouse effect, maximizing sunlight absorption. And this can be achieved through the importation of hydrocarbons, unleashing enormous amounts of greenhouse gases into the atmosphere, ammonia, methane, and so forth. Importation of algae. Algae actually breaks down carbon dioxide and generates oxygen, produces oxygen, and also absorbs enormous amounts of sunlight. So it can actually reduce the planet's albedo and maximize sunlight absorption. Also through orbital mirrors, as I've mentioned before. Orbital mirrors will maximize sunlight absorption, reducing the planet's albedo. You heat the planet, you melt the ice caps, rivers and lakes are formed and so forth. And through electrolysis, as I have mentioned, we can generate electricity on the planet and so on. And of course, as I've mentioned before, also redirecting comets and asteroids to strike into the Martian atmosphere. This will create enormous amounts of heat, which is what is needed in terraforming, unleashing CO2 into the atmosphere. As I've mentioned before, Mars's atmosphere is predominantly 95% carbon dioxide, 3% nitrogen, 1.6% argon with minimal traces of water and oxygen, as in the rest. So these are key essential points. In terms of overcoming the problems of cosmic radiation, this is a very important thing, because obviously I said cosmic radiation causes enormous amounts of health problems, cancers, double, tenfold. So this is something that we need to look at, which NASA needs to look at. In a sense, the early colonists will be guinea pigs. They'll be subjected to enormous amounts of cosmic radiation, which causes cancer and all sorts of health conditions. But as I've mentioned before, once we create structures on Mars, like domes, we can build these domes from special alloys that have the capacity to repel cosmic radiation, ultraviolet light, gamma rays from supernova, pulsars, and neutron stars, and so forth. So this is one way to obviously bypass this problem in terms of adjusting to the weak gravitational field of the planet, where we can simulate an Earth-like gravity on Mars through a centrifugal force. So science, technology, and NASA have all the mind, the brains to overcome these problems. So I will end by saying, along with Robert Zubrin, who's obviously a scientist who's actually very much behind the whole process of terraforming Mars, it's, for me, Mars has to be terraformed. Man is the consciousness of the universe. Man is the consciousness of the universe. The universe only exists because of consciousness. We bring the universe into life. We have to go beyond the boundary of Earth and start to colonize other worlds and bring the universe into being. It's man that is the spirit and the soul behind the universe. We are the consciousness of the universe. So as far as I'm concerned, irrespective of all these problems, radiation and the weak gravitational field of Mars and so forth, we have the science, the mathematics, and the brains to overcome all these problems. Yes, we must terraform Mars. I'll end with that.
Yeah,
Mhm.
yes.
Yes, thank you for joining today, and it's really nice discussions, and I think everybody enjoying these sessions, and for your nice discussions and your nice topics. Thank you, Mr. Majid, and thank you, Mr. Anthony. Hopefully, we in the future we're gonna do lot more group discussions. Thank you, everyone.
Yeah.
Thank you. Greetings. Thank you so much. Thank you.
Thank you. Bye bye. Take care. Take care.
Thank you. Bye bye. Bye.
Yes.